Let's talk about compound interest. That's when you invest money into an account and you start getting paid interest. Now, compound interest versus simple interest. So let's say if you had invested at simple interest, if you invested $100 at 10%, after 1 year you'd receive 10% of that $100, you'd receive $10, which means your tally then for the second year is going to be $110. Now with simple interest for the next year, 10%, the 10% doesn't get paid on the balance that you've got, the 10% gets paid on the original investment. So 10% of $100 is another $10, so you now have $120. And then you start the next year with $120, you get 10% added to it, so you get an extra, it's 10% of the original amount you invest, that's another $10, so you end up with $130. Compound interest doesn't work that way. Compound interest is paid upon what you actually have present in your account at the time. So if you start off with $100 at 10%, you'll earn that year, excuse me, $10, same as you did with simple. Start year 2 with 110. In the second year, you'll be paid 10% interest, but it's 10% on what your current balance is. So in the second year, you'll receive $11 interest, not the $10, which means for the third year, you're now going to have $121 in your account. And in that year, you'll earn 10% of that, so this time you'll get $12.10 interest, which means at the start of the next year, you'll have $122.10, which of course you'll earn 10% of that, which will be $12.21. So you can see with compound interest, you start off with $100, simple, start off with $100, receiving 10%, receiving 10%. But each year you get more and more and more interest being added to your account with compound interest, whereas you don't with simple, it's just $10 added in every year. So that's compound interest. Let's do a couple of questions on how this works. So here's our question. You're going to invest $3,200 for 5 years at 6% interest per annum, compounded quarterly. I'll speak about that in a moment. How much money will you have at the end of the 5 years? Now, there's a rule that we follow for this, and the rule is that A, the amount of money that you will have at the end of your investment is going to be equal to P, the amount of money that you start with at the beginning of your investment, called the principal, outside of 1 plus I to the power of N. Now, N is the number of compounding periods. I'll speak about that shortly, but it's to do with this statement here. N is the number of compounding periods, not necessarily the number of years, the number of periods. And I is the interest rate for every one of those compounding periods. What does all that mean? Well, that's the formula that the textbook uses. I actually write mine when I do it a little bit differently. I like to use FV in that position. That stands for future value. So I like the formula to be future value. The amount of money I'm going to have in the future is equal to PV, present value, the amount of money that I have now, outside of 1 plus I to the power of N. The textbook will have it written that way. I will write it that way. I like this way better because the graphics calculator that you use next year uses this terminology. So I'd like you to become familiar with FV and PV now. Not to mention, I think it makes much more sense. FV for the future, PV for the present. Now, what does this compounding business mean? Okay, let's go through and see what this question should look like. Here is our 4 variables: future value, present value, I, and N. Now, I'll start with the N. N is the number of compounding periods. So it says that you're investing it for 5 years, but it's being compounded quarterly. Now, quarterly means 4 times a year. So instead of your interest being paid to you once at the end of the year, you'll get 1/4 of the interest at the quarter-way mark, another quarter of your interest at the halfway mark, another quarter of your interest at the 3/4 mark, and the last quarter at the end of the year. That's very beneficial because once you add a little bit on at the first quarter, that ups the value of your investment. and that's what interest is calculated on for the second quarter. And that gets added on, and that ups the value of investment for the third quarter, which gets added on, which ups the value of investment for the fourth quarter, and then interest gets added on. So the more often that your investment can be compounded, the better it is for you financially. So that's a good tip to keep in mind. So compounding quarterly, the way you work that out, the end value is it's running for 5 years, and interest is being paid to you 4 times every year, so our end value is 20. Compounding periods are 20. 20 times over the 5-year period, you will have interest paid to you. Which now leads us to the I value. So the I value is 6%. So as a decimal, 6% is 0.06. But that's 6% for an entire year. But you're not getting 6% in the year. You're getting some of it in the first quarter, some of it in the second, some of it in the third, some of it in the fourth. How much are you getting every 1 quarter of a year? Well, it's that split in 4. So that's our I value. Now you could plug that into your calculator and get a nice easy decimal answer, but please don't. We don't need to do that. Some of the ones that you do, the I value is going to be a really messy, ugly, horrible decimal. Much better just to leave it as a fraction. It's going to make our accuracy much greater. Now, future value and present value. Future value is what we are asked to work out. What will our investment be worth in 5 years? Present value, what do I have now? I have $3,200. So therefore, I can now go and fill my formula in. That my future value is going to be equal to my present value multiplied by 1 plus my I value, all raised to my end value. Plug that into your calculator, and you'll see how much money you have at the end of 5 years. And you're going to have 4309.94. So in 5 years, your 3,200 turns into over 4,300. That's if the question asks you for what will your investment grow to. Now, be aware some of the questions are going to ask you how much interest you have earned. So for that one, you just do need to watch out. So if you're asked for how much interest that you've earned, well, that's easily done because you know that your account's going to have this much money in it after 5 years. You know it had 3,200 in it at the start of the 5 years. So if you subtract them, the amount of interest that you've actually earned is this particular figure. So you've earned $1,109 in your 5 years. And that's compound interest. I'm going to put a second example up, and then I'm going to leave you on your own for a while. Alright, let's see where this one leads us. Now, it's exactly the same style of question, but there's a different thing in our formula that we need to find. So what interest rate is needed? So this time, we don't know the interest rate. We've got to work backwards and find it. What interest rate is needed to turn $3,000, that's my present value, into $4,000, that'll be my future value, in 2 years' time, if it's paid quarterly. Now, by the way, paid quarterly, that's compounded quarterly. Other things you might hear say in the textbook, we might say with quarterly rests. If you ever hear the word rests, it also means compounding. And it doesn't have to be just quarterly 4 times a year. You can have semi-annually, which would be twice a year. You can have monthly, which would be 12 times a year. They're your most common ones. So, I always like to start with my rundown of my different variables. Future value, present value, I, and N. Now, future value is quite easy, $3,000. Present, try that again. Future value is $4,000. Present value is $3,000. N is quite easy, it's 2 years being paid quarterly, so 2 times 4 is going to be, so my N value is 8. Now I is whatever the interest rate is for the entire year, so I'll just use a capital I for that, divided by N, divided by the number of compounding periods, and it's being compounded 4 times. So my capital I is the annual interest rate, which is what the question is asking for. But remember that annual interest rate is paid quarterly, so it's split into 4, and that's why I've done little I as being capital I divided by 4. Capital I is what I want to find. From there, we write down our formula and just start filling it in. So here is the formula that we use, our compounding interest formula. I filled in my future value, present value, my end value, and what I currently know I to be, which is the annual interest rate divided by 4. All I need to do now is just rearrange it to make it read I equals. Why don't you pause the video, have a go at doing this, and see if you can rearrange this to make it read I equals and come to an answer. And then I'll do the work and see if we get the same result. Here's what I think it should be. I think the final answer should be 14.65%. So start bringing the numbers over one at a time. I've got rid of the multiply by 3,000 becoming divide by 3,000. 4,000 on 3,000 is 4/3. I undo the 8th power by taking the 8th root, which is 1 on 8. My positive 1 comes out to become subtract 1. The divide by 4 comes out to become multiply by 4. Notice that I haven't done any calculations so far, because 4 divided by 3 raised to the power of 1/8 is a really ugly, messy decimal. You don't want to be writing that down half a dozen times, and whatever you write down is going to be inaccurate anyway. Might as well leave it like this, totally accurate. Plug this into your calculator and you'll get 14.65. Then of course your last line should be, therefore, the interest rate required to turn $3,000 into $4,000 in 2 years compounded quarterly is 14.65% per annum. And that's your compound interest question. So best of luck on those when you get into class.